Hello, my name is Jim Tepper, Director of Products and Marketing for Etherwan Americas. I'm here today to talk to you a little bit about IoT, autonomous vehicles, big data, ultra-high-def cameras, 5G, and smart cities. That's a lot of topics to cover, but before we get into any of those details, we first need to talk about what you have today. Is your network ready for these awesome new technologies that are coming? It's a pretty big question to ask. So let's take a look. If you look under the hood of your network, if you see what's really going on there and decide, okay, do I have enough bandwidth for what I'm doing today, and will I have enough for the future? I guess you kind of need to know how much bandwidth you will need for the future, but let's start with a baseline. Where's your network today? Is it over 60% capacity? If so, you're already kind of on the borderline of not having enough bandwidth. If you're under 60% capacity, do you have enough for the newer technologies? And what are those newer technologies and how much bandwidth will they take? Well, let's take a look. Data is actually really large when it comes to some of the newer technologies out there, like autonomous vehicles or connected vehicles, some of the transportation technologies. If you look here on this particular chart, you'll see that there's a tremendous amount of data that's produced by a connected vehicle. Not necessarily autonomous, but a connected vehicle can do 25 gigs of data an hour. Okay, so, and if you start looking at an autonomous vehicle on top of that, you can see upwards of 4 terabytes a day of data produced by one single vehicle. That's a lot of data to move across a network. Now, certainly you're not going to use all of the telemetry and all the data and take that and put it across your network. But we don't really know exactly how much data we will need from these vehicles in these newer technologies that are on the road. And certainly some of these technologies will go through a cellular connection, 5G or 4G. But and when you're talking about vehicle to infrastructure, these connections will be to an intersection or a roadside cabinet or a gantry. All of those things will have a receiver unit, and data will be received by every single car that passes it. As a comparison on this chart, you can see just the streaming services that you might use on your phone today and how much data it takes. Doesn't even compare to the amount of data that will be produced by intelligent vehicles and autonomous vehicles. And of course, we know this is coming, if not already here in many instances. Now, this is one aspect of your network needing to have enough bandwidth to support these technologies. If your city or state or country has an initiative to improve your infrastructure, this is likely going to be a large part of it. But let's look at, why is this data even important? Why do I care about the telemetry of a vehicle? I mean, isn't that just extra data that's not really critical? Well, it turns out your life may actually depend on it. Let me give you some examples. If you look at the red light violations, or if you come to a traffic signal and it's red, some people may accidentally not be paying attention or run through that red light or not adhere to the warnings. This in the US alone causes up to 2,000 fatalities a year. And of course, over 250,000 crashes. This is kind of a big number. So by implementing this new connected vehicle technology, you could reduce that number drastically. Also, when you exit a highway or a tollway or a high-speed thoroughfare, there could be some on-ramps or off-ramps that are very tight. And sometimes you need to slow your vehicle down in order to go on that road to make your exit. Well, this actually results in 5,000 fatalities a year and 160,000 crashes. So these exits and ramps account for a lot of problems. But what if there was a technology to warn the driver that these were coming up and that their speed was too high for these exits and turns, or that they're going too fast to slow down in time for an intersection that's about to turn red? These are the technologies that we're looking forward to in infrastructure. So it is a matter of life and death in a lot of these instances. if you look at traffic management applications in general in a city, you can reduce crash-related incidents by 25% due to weather conditions. Now, I live in sunny California. It's very nice out, and we have weather events here, but generally they're wind. That's not really a major weather event. But in other places, they have hailstorms, thunderstorms, snowstorms. They might have ice on the road. There could be a sandstorm. There could be low visibility due to fog. All of these things can affect a driver's ability to make a decision in time. But with technology used in connected vehicles, this can be avoided and deaths can be saved. But okay, maybe you're not so much into the touchy-feely, let's save lives. Maybe you're more about business. Okay, so if you're about business, you can see that also these connected applications can improve the ability to go from a sporting event to a bus, can reroute traffic dynamically, can save time on highways by platooning vehicles together. You could also do priorities at signalized intersections for vehicles that may not be able to slow down in time, like a large freight truck. Or maybe it's mass transit you need to make sure is kept on schedule. All of these technologies can help reduce travel times by 27%, and on the highway up to 42%. So again, connected vehicle technologies are very, very cool, but can you really do these technologies with your existing network? Is gigabit enough? Is 100 meg enough? Maybe you have an older network. Maybe you need something faster to take advantage of these technologies that save lives and improve efficiencies and basically give you a better bottom line for your dollar and maybe keep you out of traffic. But what about other applications? So other applications might include cameras. Have you ever put a camera on a network before? Of course, everyone has. But more and more cities are putting more and more cameras up. And more cameras have higher and higher resolutions. And the higher resolutions and the more cameras you put up, the more bandwidth you need. Now, cameras can help with even connected vehicle applications, but of course, they're mostly used for security today. But all the analytics that come from cameras are quite important for the future technologies of smart cities and IoT and et cetera, et cetera. So in this case, we really need to pay close attention to how does a camera really affect the network. You might ask yourself, well, how much bandwidth does a camera need? And the answer really varies. I mean, if you look at a standard 1080p camera, when we did a survey, you'll find that some people say 2 megs a second, other people say 6 or more megs a second. Who's right? Well, the answer is it really depends on your network. But just knowing that means that, wow, there's a lot of variability in how much bandwidth could potentially be used, especially across a large number of cameras. So how do we figure this out? Well, it turns out there are camera bandwidth estimators that you can go to and get a kind of a baseline knowledge of how much bandwidth you might need for your network. And then you start to think, well, is gigabit really enough? Do I have enough bandwidth on my current connection? And then you might start to think, do I want to upgrade in the future? Will I be adding cameras? Will I be changing the resolution of some of those cameras in the next couple years? Should I plan for that today? How important is your data today versus how important will it be tomorrow? It might become much more critical tomorrow. So therefore, you should start planning today. These are the types of questions that lead you down a path. And then you start to think, okay, well, how does a camera really affect my network? How should I plan for it? Things happen quickly on a network. They happen as fast as a millisecond, or even faster in some cases. A bee flaps its wings in 1 millisecond. So one flap, 1 millisecond. That's pretty fast. To put it in perspective, a simple eye blink is 1/10 of a second. So a millisecond is very, very fast. So we need to really look at what the network does, maybe on more of a network time scale. Instead of just by the second, we can start looking at other things. So for instance, If you look at a network and you see a chart here and you look at all the cameras that are basically sending data on this network, and you'll see that 10 meg, 10 meg, 10 meg, all the way down to camera 5, total bandwidth used is only 50 meg. 5 cameras, 10 megs each, 50 megs. I have a 100 meg network, so no problem. I'm only at 50% utilization. This is great. My world is complete. Now let's look at 1/10 of a second. Okay, if you take that bandwidth and you do a measurement using Wireshark and you do a 1/10 of a second measurement, each camera is about 1 meg of bandwidth. Your total available bandwidth is 10 megs. So I have 1 meg, 1 meg, 1 meg, 1 meg, 1 meg. So 5 megs total. Total bandwidth 10 megabits. Again, 50% bandwidth. That's fantastic. But remember, networks operate at the millisecond level. They operate faster than the 1/10 of a second level. So if we go one step further and go to 1/100th of a second, you start to see, oh, wait a minute. If I add up the bandwidth from each camera at this 1/100th of a second example, all of a sudden I'm over my bandwidth. How is this? Why is this happening? Well, this is called camera bursting. So sometimes cameras need to refresh the entire image or kind of do a high-res keyframe. And when that happens and it all lines up all together with other cameras, there could be a very large burst event on your network. And you might see this on an IP camera in the form of a pixelated image, as you see here. It could be pixelated. You might see a frozen block. You might see the whole image completely freeze, depending on how bad that burst is. So what's the solution here? Well, certainly you need to understand the bandwidth situation. You probably need more bandwidth, yes, but how much more? Well, this is an easy calculation you can use. If you have a simple camera stream at 1 megapixel, for instance, and you have 2 megapixels, or I'm sorry, 2 megs a second for that 1 megapixel camera, generally what it's sending. That's just one stream. What if that camera's sending 2 streams? You have to account for that too. That could be the sub-stream. So you have to add that in when you're doing a calculation. But let's just say there's only one stream from this camera for a simple example. A 2 megapixel stream can burst up to 6 megs per second on the network. So even if your network is 50% full, if you have a burst on cameras and the majority of your network is camera related, you could easily hit your maximum bandwidth and thus cause some pixelation on your camera images. A lot of people don't realize this, but it's because if you take a look deep into the network and at a very high speed, you'll start to see, oh wow, that burst is actually affecting that 1/100th of a second, and that can cause a data backup. It can cause a loss of a packet and a retransmit, all of those things, and that affects your picture quality. So really the moral of the story there is you need 10 gig. You need more bandwidth. The more bandwidth you have, the more leeway you have, the more flexibility you have in your network so that you don't hit that maximum speed when a camera burst happens. Now with EtherWAN, we have a variety of 10 gig solutions to help with these bandwidth challenges that we have just talked about. But before you go down the path of IoT or 5G or smart cities or connected vehicles or any of these new technologies that are coming that are really, really awesome, you have to ask yourself, do I have enough bandwidth? And if not, maybe it's time to think about 10 gig. And not just 10 gig either. Maybe you want to start looking at other technologies to help in the short term to maybe keep your network running. Things like managed switches and picking switches like EtherWAN switches that have bigger buffers than the competitors so they can help absorb some of those big camera spikes that can happen out there or bursts. You can also implement segmentation in your network, which is the ability to use different zones and or subnets to help divide up traffic to lower the amount of background traffic or broadcast traffic that can be happening that could potentially saturate the network and cause video performance to suffer. So this is just a taste of information that you might need to understand about your network. Do I need 10 gig? Where is my network today? And wow, these cool new technologies are great, but maybe I'm not ready. Maybe I need to get ready. To find out more, of course, you can go into the details with your local EtherWAN representative or go online and learn a little bit more on EtherWAN Academy. It offers free networking training and it goes a little deeper into some of these topics that I just mentioned. Well, that's it for now. I hope you learned a little bit more about network bandwidth, upcoming technologies, and whether or not you or your customer may be ready for these technologies. And if not, maybe it's time to talk about 10 gig. Thank you.